Today, we're going to talk about CNC machines. Usually in the normal course of a semester, this is your final. This is not your final, all right? But your final will be something very similar to this. So for the final exam, what I normally do is we come in for our 2 hours, or 2.5 hours, however long it is, and I bring a part in SolidWorks. I don't do SolidWorks, but I program Mastercam, and what happens is you get to see me program a very simple part. We generate the G code, which I'll talk about in a moment, and then we go out to the CNC machine and load the machine and run the machine, okay? That's a very simple part. That is usually your final. Your final will be something else I haven't decided yet, to be quite honest with you, and what project it's going to, or what part it's going to be, okay? But we're going to do the CNC thing today. What we're going to do is the top, the aluminum top of the lap steel, that shape, okay, right? But before we do that, we need to talk a lot about what CNC is, and a little bit of history maybe, and how it its concept, and it's the theory behind it. Not going to get into detail, okay? So first of all, what CNC stands for is computer numerically controlled machining, actually, okay? That's what CNC stands for. The way that the CNC machine works is, the way that it moves is based off of a language called, well, actually it's known as two different. It could be generically known as NC code, okay? What that stands for is numerically controlled, all right? Numerically controlled. Just real fast, I've already seen that. Or you can be a little bit more specific, and it is what's known as GNM code, okay? Code. We'll talk about that in a moment. And so the GNM code are the commands that the CNC machine takes to perform a move, to change tools. Its spindle speed, its feed rate, okay? So very basic, that's what that stands for, and that's how it functions. Now, all right. You need to know how to machine to be a really effective CNC operator or programmer. There's a lot of dispute about that, and I'm not going to say it's impossible. You might just be able to do it, but I can tell you from experience that to be really good at CNC machining, whether you're programming or just running the machine, you do need to know how to machine. You don't need to be this amazing manual machinist, cutting gears and tool and die maker type stuff, but you do need to know how to machine. You need to know how to pick up on the way things sound, like when it's cutting, if it's cutting too hard, too fast. You need to know how to machine. Here at the school, a lot of people seem to think that I get a lot of, "Hey Blake, you just CNC this for me," and it's like what am I going to ESP the program over to the machine and push go, and the part just magically comes out? So an example would be a plate. Let's say we had a 6x10 aluminum plate, okay, and it had a bunch of holes in it at different places and different sizes, okay. You guys have seen me do this now enough to know that it's I can probably do this plate with a bunch of holes in it manually before I even have some of the computers here started up, okay? And let alone writing the programming in Mastercam or in generating the G code. Then I have to go set up the machine. I'll just crank this out manually, all right? So why then would we have CNC machines? And so we're going to talk about two different areas of that concept. Why do we have, if I can do it faster manually, why do we have them? Okay, well, there are some things that are really hard to do on the mill and the lathe, and I'm never going to say they're impossible. There's always a way to figure it out, okay? But there are some things that are very difficult. So let's go look at this plate again. And let's say I had a hole here that was a very odd size, okay? A very odd size. Let's say it was going to fit a 1-inch bearing. So I would want this, if I was going to fit a 1-inch bearing in here, I'd want this hole to be exactly 999. Okay? Then let's say at the same time there was another one over here, and I want it to be 1999, and then in the center, I don't know, I'm just making this up, we put some sort of optical lens in here, okay, and it actually needs to like sit in there just perfectly, maybe, and it's like 1.499, all right? So this is very possible and very easy to do on the mill, okay? But it's going to take a long time. So, and also, let's say I wanted 5 of these, 5 times, okay? I could crank this out in the CNC machine in a couple hours, okay? Whereas it might take me, if I needed 5 of these, it could take me a couple days, or a whole day, or a day and a half to do, okay? So that is why one example why a CNC machine would then be used, all right? If these holes that were in here that I just erased were just like normal hole sizes from the drill chart, we're not doing that, okay? We're not going to CNC that. Now, the other thing about a CNC machine is, let's look at the top view of the milling machine. And those are the T-slots, right? And here's our vise handle. There's our vise, okay? So we know now that we can move Y this direction, and we can move X this direction, and we can move Z up and down too, but let's not talk about that yet, all right? With a CNC machine, what we can do is we essentially are attaching motors on these axes that are calibrated and controlled, so we can make color, we can make profiles, like I can put a block of metal in my vise, okay, and I can make a profile that look like that, okay? And that would be next to impossible to do manually on the, actually it's not, but it would take days to do on the manual machine. Because the motors are going to move the table, right? Okay, all right? Okay, let's add an axis. Now, we've got side view, okay? Looking at the mill this way. Here's the spindle with our cutter, okay? We've got X, right? We've got Y. That, right? That way, okay? And we've got Z. And it can move up and down. Now, if not only can the table move and cut that puzzle-like looking piece, we could add a second profile to it. So here's our part, and the top of it could have like a wave pattern in it. Okay, now that is what's known as 3-axis CNC machining. Okay. What this the slang term, or I don't even know if it's slang, this is called what's called a live Z. Okay. Because now not only are X and Y moving, but Z is moving up and down too, all at the same time. Alright, so now it's starting to get really cool. I'm going to stop there because we can add, actually I won't. We can add another axis. We could put a rotating chuck here, okay? And our part would be hanging out here. Now the tail's moving around, now this move up and down, and this is rotating, okay? That became a 4th axis, okay? And we can also tilt this spindle like this too, in like a circle, okay? Like right on a circle. That, if I do that, that became a 5th axis. Now I'll stop. It can go further. Okay? So now, if we were to use all these 5 axes, we're moving X, we're moving Y, we're moving Z up and down, we're spinning, and Z is not only moving up and down, but it's rotating like this. So it's moving up and down, and it's rotating like this. Okay? Yeah. All right. So we're going to stop there on that. Now we're going to talk about how this programming in this code is generated. Okay. In the 60s, in the early 70s, they used actual punch tape. So it was like this tape, and it had little punches in it, and it went into the machine, and it told the motors, or the computer in the machine, what to do. We don't do that anymore. And then, when computers in the 80s got smaller, right, and they actually started to buy them, we started writing the code manually. So we would write the G code manually. Bear with me on the G code, okay? You're going to see actual G code, and you'll know totally what I'm talking about. Okay. Then later, and I don't know exactly what year it happened. I should look it up. I don't know. We got software that what we were able to do is load in our part into software, or draw our part in the software, and we were able to program, keyword, program the toolpaths in software. So we were able, so this is our block, okay, and we had 4 holes in it, and I don't know, another puzzle piece in the center, okay. We were able to say, first thing, to the software, drill these holes, okay, and then come in with a 1/4-inch end mill and do this profile, okay. And it would program that software to do that. And it had also built into the software is what's called posting. Come on, Blake. Shoot, I'm just not. I lost it. What it's going to do is it's going to look at what you programmed and generate the G code for you. So you don't have to write, okay, thousands of lines of code and then go back and find out you made mistakes here and there and have to go back through all the code to figure out what okay? So it's going to generate, actually let me do this this way. It's going to generate the G code for you, okay? And so typically, the way this goes down is you are going to create some sort of digital file. Okay? And that can be in AutoCAD, could be in SolidWorks, could be in all kinds. CATIA. I think there's Fusion 360, or it could actually be in your toolpath software as well, which in this case, and I'm going to put that in blue, at school and in aerospace industry, they use software that's called Mastercam. And okay. What is Mastercam? Mastercam is software that is used to program your toolpaths for you, like drilling holes and cutting contours and profiles and pockets. And then it also generates the G code for you. You can also draw on it as well, and you could skip these three, and you could just draw your part in Mastercam too. Okay, you can do that. Just off the top of my head, there's other CAM software, and that one of them is GibbsCam. GibbsCam is one of them. Believe it or not, SolidWorks has it built in now too. I think there's even a Mastercam addition to SolidWorks, which finally that's great. What does CAM stand for? Computer Aided Manufacturing. Okay? So CAM stands for Computer Aided Manufacturing. What does CAD? Oh, wrong code. What does CAD stand for? Computer aided or assisted drafting. All right. I guess I'm not too sure about now what to say about 3D modeling. I think that they fit into this. That's something I need to research to see where exactly, like technically, textbook, where 3D because this is 3D modeling. You can draw 2D and make two-dimensional drawings in SolidWorks. Now all these you can, but primarily their role is 3D modeling. Okay, and I think it's still in computer drafting. I need to look that up so I'm more clear about that. Okay, so let's not lose it here. So we need to create a digital file of some sort. We need to then use a toolpath software to program our toolpaths. All right. And then once that's done, we move into another software package that we need something to generate our G and M code, or RNC code. Okay? That is the steps of what it takes to then put the part and load the machine, the CNC machine. Okay? Like I said, this is very basic CNC operation and programming. I wouldn't say it's like totally crazy hard. It is, and especially when you get into 7 axes and 6 axis machines. But I mean, we can talk about this for semesters, plural. Okay, so this is very, very basic. This is just like everything else. It's just so you know when someone says CNC machine, you know this is what they're talking about. Okay, and this is a very, I wouldn't say this is a very basic process of how it's done. All right. So now let's move into a more technical about the machine. Okay. Let's look at the machine. And okay. So if I put a part in the machine, we're going to look at the top view. Here's the table of the mill. So just imagine the mill, only now there's motors attached to the handle. Okay? And there could be a vise, anything. Let's use a vise. So let's put a vise in. So here's our vise. Right? Here's the handle. Okay. And we're going to put a part in the vise. Our material in the vise, right? Inside this machine. Does the machine know where this part is? Absolutely not, okay? We need to tell it. So, lately I've been working off of these corners, right? So that would be, a corner would be a great place to say, hey, this is where what they call user home is. Okay? I'm not even going to write it down yet because there's something else. If we walk up to the machine and hit on, just turn it on, it has no idea where its Cartesian coordinates are. It has no idea. We turned it off. All the memory has been wiped. It has no idea. Okay? So what we need to do, the very first thing we need to do on the CNC machine itself, is we need to send it to what they call home. Okay? And that is what's known as, so number one thing is we need to send it to machine home. Okay? And machine home on most machines is down in the lower left-hand corner. So there is, I'll just say, machine home. And it does it. There's little limit switches, okay? So it knows when the table, it goes real slow, it goes and comes in and it finds machine home, all right? Now it knows where X and Y is within the realm of the machine, okay? So the second thing we need to do, there's more, but I'm keeping it basic, is we need to establish where this corner is. That is what's known as user. All right? And guess what? There's a G code for that, which is, one of them is what's called G54. Okay? That G54, if you see G54 and you see X at 3.524 and Y at, I don't know, I'm just making this up, 6.423, what this just said to the machine is, my user home is at X 3.524 and Y at 6.423. We told the machine where our user home is. Okay? That means that from our user home, if I had holes in my part that were 1 inch over on X, where's it going to move? it's going to move to 4.524, because now it knows where it's at. Okay? All right, so that's super important. Okay. The other thing that we have to do is let's look at the front view. And off to the side here is what's called a tool changer. All right, don't worry about it. And here's our spindle with our tool in it. Okay, and we've got, I don't know, let's say we got 4 tools in here. We've got a drill. We've got another, I'm just going to say another different size end mill, and we've got a center drill. Okay? And here's a different size end mill. The CNC machine has no idea where the relationship to the bottom of this tool is to the top of our part. Okay? So what we have to tell it what that is. So remember, it went home. It knows where home is on Z now. We need to give it, so what we do is we'll lower the spindle really slowly. I'll use the piece of paper trick, okay? And I'll give it a tool offset. More specifically, I'm going to give it a tool height offset. If I wanted this end mill to come and cut only like a 1/2 inch deep, it needs to know where the top of this is. Okay? So these are all things that we need to do before we even start our program. Okay? We load all this information in the machine, which you're going to see very briefly, and right, and yeah. Yeah, very good. That's it, okay? I feel like I'm missing some stuff. I think I forgot something. But I think also that these videos have been really long, and I'm trying to give you guys a little bit of a break here, and just, it's very frustrating. So, not you, the situation. I think that just about covers it. What I'm going to do is you're going to watch me load the machine. I'll put a lot of it in fast forward. We'll start the machine, get it going, and then I think I'm not even going to film most of the process, okay? I will take shots, like quick 30-second shots, and maybe some cool stuff I'll put into fast forward, all right? Yeah, and if I think of anything that I forgot that I really thought was important, that I really forgot, I'll throw that in there. Okay, let's go. Okay, so here's what we're doing, all right? We're going to make that top like I had mentioned. And it's really hard to draw, actually. I'll do my best. And it looks, something like that. And it's got a shape of it is more like that. And it's got a through, so it's not a pocket, but it's got that where that one pickup goes in here, and then it's got another. You guys have a drawing, all right? And it's got a hole here for a volume knob, a hole here for a tone knob, and then it has a hole here for a switch, and then it's got a bunch of holes like around the perimeter. Okay. It's got 4 holes here, and then it has 3 holes for the bridge. Something like that. It's not at all what it looks like, but it's close enough. Okay. We're going to be making this out of a piece of aluminum plate that's 3/16 thick. So I've touched on it a few times before. When we make parts, whether they're CNC'd or they are made manually, if at all possible, we always want to drill the holes first, okay? The reason for that is because if you have holes in something, typically something bolts to it, or it bolts to something, and sometimes, not always, sometimes some of the other operations in that part aren't as critical as those holes. Not always, okay? This is just, okay? And things move. When they're in the, even though you think, no way, you got like all that vice pressure and clamping force and all this, you know, these hold down fasteners and jigs and all this, things move. And if we get our holes in before things move, then there's a much higher chance that the part won't end up in the recycling bin. Okay, so that's like, so if you, when all possible, no matter what you're doing, wood, anything, you always drill your holes first. Okay, kind of there's the tip of the day. Even though I've mentioned it before quite a few times. All right, so what we're going to do here in our order of operations to do this is this plate is, I'll just draw through that. It's like this, okay? And it's a plate, 16 by 11, I think is what it is. We're gonna not use the vise. We're gonna hold it down with step locks, okay, which I'll show you. And but what we're gonna do, like I said, the order of operations is going to be coming in with a center drill and center drilling all the holes on this plate. So the first thing we're going to do is center drill. Then the second thing we're going to do is I'm going to come in with a drill bit and drill out all these holes. Okay? So the perimeter holes. I think that's, I don't remember. It's a 64. I don't remember what it is. And then we come in here. I'm sorry, the pickup holes, and we drill those out for a. So the pickup holes with a number 43 or 44, which reminds me. It's not really the best idea to try and memorize all the tap drills, because we're gonna tap these. It's better to look them up. Don't try and memorize them, because then you get confused like I just did. Then we're gonna do the bridge holes. The bridge holes, okay? Then we're gonna do these holes here, so the control holes. And then number 6, we're going to do these pockets. They're not pockets, they're all the way through, so I'm going to call them actually contours, because that's what they are. Alright. And I'm missing something. I don't think so. And then we're going to, after that's, oh yeah. Okay, so then, I think you can see it if I write it over here. What I did not include on the PDF for you guys is I did something. I did a bunch of engraving. I did a bunch of drawing, and so we're going to do a lot of engraving, and that is really the time stuff. in the CNC. What I'm going to be using for the engraving there's a pattern, there's a design on here, okay? I'm going to be using a 1/16 ball end mill, a 1/8 ball, just for some highlights, and I'm going to use a 1/8 engraving tool. So you know what you know what a ball end mill looks like. So a 1/16 diameter ball end mill, right, is really, really tiny. It's tricky. I'll explain it while we're doing the video, okay? While we're doing the CNC stuff. But an engraving tool is actually I'm going to draw it in two views. So the front looks like this, and then here's the shank, and this is round, so this is the shank. The side view actually looks like this. Okay? So it's got a tip on it, but it's like round to the tip, but it's like flat. It's like cut in half. And then this is the shank, and it's round, okay? And this is an 1/8. So these three tools are, needless to say, extremely small, and they're going to be doing some engraving. After the engraving is done, I'm going to come in with a 1/4" end mill, and this is really what I want to talk to you about. And I'm going to do the outside contour, okay? Okay. And this is really what I want to talk about. But this is what we're doing. So let's say I take a 1/4" end mill, and I'm not going to do it in one pass, so I'm gonna, it's going to be multiple passes all the way around. What starts to happen is when I bust through, okay, when I'm getting around and I get about maybe just a little bit past halfway, the actual part is going to start vibrating like crazy. And what's going to happen is it's going to actually ruin the part. It's going to vibrate so much that the edge of the part and the edge of the waste material is going to be completely annihilated, all right, by this vibration. So, what you can do, and what I've done in Mastercam, is I've programmed in what are called tabs. This isn't their exact location, but it definitely is close. I think it is something like this, actually, okay? And what these are these tabs are when this 1/4" end mill comes around. Now, I'm enlarging this, obviously. This is way bigger than a 1/4". But this is the profile it's going to be, and cutting away, right? Where the red marks are, it's not going to cut away all the material. It's going to come near, and it's going to lift up, move over, and then come back down. So when I take the part out of the machine, when I'm all done, it's going to all come out with the sides and everything in their tabs. And then the post process is what it's called. Is I'll take it over to the vertical bandsaw, and I'll cut this out. And then I'll either use a disc sander or files and sandpaper and get rid of the tabs altogether. All right? So this trick, yeah, not too trick, all right? But it is. I mean, it's like kind of cool, right? We're doing the whole thing. So you guys know that I could have done all the holes based off of a corner in the mill, right? That doesn't matter where they are. They're all XY coordinates. I could have put in, you guys know, she saw me do this. I could have put these in, I could have put that in, but putting this in on manually, I couldn't have done that on the mill. What I would have had to have done is draw this out, bandsaw it, and then clean it up with files and sandpaper. And that would have taken a very, very, very long time. So not only is this going to be perfect because it's CNC, but it will be done very quickly. The runtime in Mastercam is about 2 hours and 45 minutes for the whole thing, including the engraving is actually like over 2 hours. Okay, yeah, I went over the top of the engraving. Don't worry about it, it's a surprise. Maybe you'll dig it, maybe you won't. And yeah, that's what we got going on. Like I said, the engraving is way over 2 hours. If there was no engraving, this part probably could be done in about 20 minutes. With about 30 minutes of programming. And 20 or 30 minutes of setup on the CNC, and then the runtime would be roughly 20 to 30 minutes. Okay. My user home is going to be this corner. Okay. So just so we have a little game plan, so when we're on the CNC and I'm saying, oh, this is my user home, you at least know, the order of operations, you know what's going on. Okay. Hope that was clear. I think so. I'm actually really excited to do this. I think it's going to be really cool, and I think you'll dig it. All right, we're doing it. All right, so here's our material. Here's our material. I sanded it. I think that's going to be okay. It's not fantastic, but I just wanted to. I'm not going to polish it. I just wanted to get rid of any of the, any kind of crazy scratches. And it's 3/16. You can see that, okay? What I did is I made a little template. I don't need it. I just wanted to show you what this looks like on here. So this is what we're going to be cutting out, and then the aluminum that you see is going to be our waste, okay? What we're going to do now is, like I said, I don't need this, but I'm going to use this so you can get a visual representation of what I'm seeing, all right? What I'm going to do now is I'm going to go over to the CNC machine. I'm going to turn it on, and I'll just explain to you what I'm doing, okay? So turn it on. Oh, close the door. Yesterday, I loaded some tools already in the changer. I'll show you that, of course. But so I have one left to do, and we'll do that, okay? So you can see me put a tool in a collet, and we'll run through all that. So we're just turning it on. It's got a, load. It's operating system and software here. Normally I wouldn't do this for like a video, but I know that none of you have probably seen this before, so that's why we're going the long route. All right, yep. So let's take a look over here while that's going. Okay, so this is a CT40 collet, okay, and that's right. And it's a 40 taper, okay, and that's actually the tool we're going to use. And what I'm going to do is I'm going to take this out so you can see all this. All right. Okay, so there's a 3-flute solid carbide 1/4-inch end mill, and here's the collet, and move. Paper towel. Here's the collet. I thought those were chips. They're not. It's real important that there's no chips in here, okay, and that these are clean. You gotta, if you really want your tooling to last and to be accurate, and precise, and that's the real reason for a CNC machine anyway, you really need to take care of this stuff, and I don't think we're taking the best care of this stuff, unfortunately. Okay, so this you don't just, you have to click it in there, okay? And then I usually start this like that a little, and then I'm going to put the tool in here. Okay, got like there. And then take the wrench and tighten it up. There we go. Okay. So that's ready to go. So, all right, now we are back here. It looks like we are on. It's ready. And the newer machines, the newer CNC machines are great. They really tell you, they almost just tell you what to do. So it says, hey, cycle the door. Okay, I just cycled the door. Okay. And it says check, and you know, the emergency stop button, it's already, you know, it's out, so it's okay. And then it says press power up. Well, what power up is what it's gonna do, it's gonna, because I just turned it on, it has no idea where machine home is, if you remember. It's gonna find home, okay? So here it goes. And it is now going to find home. I have to leave the door closed, unfortunately. I think I'm gonna try and clean the glass so we can see better. Okay, so it just tried to load tool number 1, all right? And that's a 20 tool carousel in there. I'm actually, let me see if I can clean this. Oh, that's better, okay. And it just tried to load in tool number 1, but there is no tool in tool number 1. And there isn't one for our program. I programmed for tools 4 through 11, and there's a reason why I did that. I'm not even going to get into it. It's actually the problem. There was a problem. The problem's been fixed. So I'm not going to talk about it. So okay, so now the machine, the table just went to the lower left-hand corner, and that's machine home. The spindle is at 0 or tool loading position, okay? All right. So what I gotta do now is I'm gonna load my last tool that you just saw me put together, and I'm gonna have to put in my material, okay? So I'm gonna go to what's MDI, which stands for manual data entry input, and I'm gonna tell it to say, hey, what tool do I want to go to? Well, let's just see. Let's go to a tool that's already in there. Let's go to tool 4, 5. Let's go to tool 6. So, hang on. What? Hang on. Hang on a minute. What does it want me to do? Oh, we're good. Okay, okay, we're good. So let's go to tool 6. So it's gonna load tool 6 now. Okay. We want tool 8, I believe. And so, just showing you. So I can go to tool 8. All right. And I'm gonna load tool 8. So make sure, I'm going slowly, it's very hard. Make sure you can see this. Okay, so I'm gonna put that in there. There's a tool load button right there. I'm lining up this, okay? And it grabbed it, all right? And I wanna load my material, and so next, and what I've done is I put an indicator in one of the chucks, okay? And so we have to close the door. And so what I'm gonna do now is I'm gonna load that tool, and that's tool 7. Okay, so I got my indicator in there, and now, you know, there's no wheels for me to move the table, so I'm gonna do it via the interface. So it says handle jog, and I select which axis I want to move. In this case, it's X right now, so X, and now I can move move the table, okay? And I'm gonna want that to be pretty centered. And let's open the door, okay? Grab material. Let's see. Okay. And I brought some parallels from the shop, and put these down like this. I'm gonna put this here. Alright. And really I'm gonna put my phone in the middle so you can really see what I'm doing. So actually, okay, one moment here. Put this down. Just gonna grab a paper towel and make sure that it's really clean. I already kind of did this, but I really want you guys to see what it takes to do this. It's not, you just don't walk up to these things and push go, all right? You really got to kind of know what you're doing, all right? So I'm gonna put this down again here. And thinking, you know what, I'm gonna switch these. You'll see why in a minute. Switch this around. This over. Yeah, this is what we'll do. This is what we'll do. Okay. And now what I'm doing is I'm lining up. That's the side I want. Yes, I'm eyeballing it. I'm using the T slot, and I'm just eyeballing it and making it as straight as I can along that T slot. Okay. And I know I need these corners. And I'm gonna grab the template too, so you can see what I am seeing. Okay, so it's about like that, okay? Make sure everything's going okay. All right, and I'm getting as much of that parallel under there as I can. Not underneath my part though, all right? And definitely not in the corners. Okay. These are called step blocks. And the way that they work is that there's a T slot, a T bolt. See this bolt there? I know the light isn't the greatest, at least there is light. And then there's the step block, and they kind of lock together like this. So I'm gonna slide this in the T slot. I'm gonna slide the T bolt into the T slot and put this over my parallel. So what I'm gonna do is clamp my material down to the table, not using a vise. Yeah, there we go. Hopefully I'm gonna need shorter bolts. Pause. I need shorter bolts. I'll be right back. All right, so I got some shorter bolts, and looks like that's gonna work pretty well. And I saved a little bit of video time by putting some stuff in, putting some clamps in place already. And I'm just gonna hand tighten this, okay? And grab another one over here, make sure it needs to come down a step. Want this to be what I'm after, just so we're clear, is I want there to be metal all the way through. I've already got a problem here. I've got a problem of deflecting in the middle. Okay, so when the cutter comes down, it's going to deflect my part. All right, so that I already know, but it's a musical instrument, not some sort of optical testing device, right? So we can do a very basic setup as opposed to you know, going crazy with some very rigid system. So and I already see another problem, okay, and I'll show you that in a minute. But since I have this tool and the indicator in here already, I'm just going to get this set. So that looks pretty good. All right, and only thing I'm worried about is if I have enough Y travel, but I think I do. And so what I'm going to do is I'm not going to tighten these. They're hand tight right now, so I'm just gonna barely snug them up. I don't like using these types of wrenches, but this is what I can find in this, because I'm not in my shop, just in case you guys didn't know that. Actually, I wonder if this is the right. See, I had trouble finding. Get rid of this. Okay. I don't like adjustable jaw wrenches. They strip everything. Okay. I can't feel as well. All right. So I just snugged those up. I barely. What should I say? Oh, and I got another thing I want to do. I barely tighten them because I'm going to move around this plate. What I'm going to do is that. Just move this back a little. Let's see. Sorry, I'm thinking now. I want to be able to get that indicator over that parallel. See, it's in the parallel's in the way, and I want to get that. That should be good enough. Yeah, you know, it doesn't need to be perfect. That's right. I gotta remember, Blake, it doesn't need to be absolutely perfect. All right, so we're good. I'm gonna have to make one thing. So what I'm gonna do is I'm gonna run this indicator along this edge, and I'm gonna tap the plate in place. You'll see that now. So I'm gonna hand jog the table over here, and then I'm going to bring down the spindle. My phone's so far away from me. Okay, so let's see if I can make that clear. Yes, we got it. So I'm going to lower this onto that indicator. Okay. And now I'm going to put the traverse wheel into thousandths increments. So now it's moving thousandths of an inch. And so we can watch in a moment that indicator will start to read for us. There it goes. So for every move, every tick on the hand wheel, I'm moving the table, okay, 1/1000th of an inch. I don't need to put it on 0. I want to see how straight this is. So we put it in Y. Oh, so X. Oof. All right, and I'm gonna move this back and forth here
without crashing the indicator. So what's that say? That says 45 thousandths, okay? If I go to the other side here, I'm 9 thousandths out. So it's cocked this way, right? A little bit, because that indicator said 45 here and 45 over here and 36 over here. So you're right, it's heavier this way because it's as you push in on the indicator, okay? And so if I wanted to, I'm going to very lightly give this a little tap. Now, I actually don't need to really be doing this, but I wanted to show you anyway. So I'm in X, and let's see what my tap did. It's close. My tap moved it about 4 thousandths, okay? So I'll put this back. So I'm about 6 thousandths, all right? I'm just gonna give this a little, might have been too much. And let's see what this says now. Same. All right, let me give this a little tap. I don't need to do this, but I just wanted to show you this is a setup procedure to get a plate in. All true. So now I'm at 40 and I'm at 35, so I'm 5 thousandths out. Let's see if I can get this. Too much, but let's see what happened. That was too much. Okay, I was wrong. So that says 34 on that end. And it says about 33 on that end. So I'm 1 thousandths over this distance, so about maybe 8 inches, 7 inches. I'm 1 thousandths out. So I could, work on it. I could tap it more and more and keep working on it. But I'm not going to, because I don't need to do it anyway. I just wanted to show you, okay? And then, actually, before I do that, before I remove it, I'm gonna go ahead and tighten up my bolts. And I'm gonna check it again. Now, there's other ways to do this, just so you know. I like to do it this way. I also sometimes don't use this tile indicator, but I chose it because I thought that it would be easier for you guys to see. All right, so make sure okay. And you don't need to crank the daylights out of it. You just need these things to be tight. Okay. There we go. And now I'm just going to check it one last time. Make sure I'm X. See, often it moves after you tighten it. And so you can see it moved the thou after I tightened it in non-favorable position. So that, make sure you can see it. So that indicator there says 35, 36. I'm gonna call that 36. It's a little below it, but it says 36. Okay, and as I move X, the needle is going off of surface imperfection. All right, there it is. So that says 33. So I'm 3 thousandths out. All right, but you can see I can tap on it, and it was about 1 or 2 thousandths out before, and then after I tightened it, it moved on me. All right, but we're good. So what I'm going to do now is I don't want to crash my indicator, so I'm going to Z up the spindle. Okay, so I'm going to go Z, and I'm going to raise the spindle. All right, and I'm going to take the indicator out of the chuck, lay that on the bench, and I can go ahead and bring my part, my material, bring the table back towards me, because I got something I want to show you. So Y, oh, there we go. All right. So I'm going to go ahead and I'm going to load a tool here, and I want to show you something that's going to happen that's not good. So that's, what do we got? The one we just did. So I'm going to have to close the door. So, let's see. Tool 8. Now, this is that 1/4 inch end mill. Okay, we just put in, and it's gonna cut out the pickup pockets, right? But it's also gonna cut out my perimeter, and I'm not in danger of the tool hitting anything, but there's a possibility, which I don't think will happen, but I'm going to do it anyway, that the collet could hit one of my clamps. So we could check it. Why don't we do that? Let's just check it, and maybe we won't have to. What I was gonna do is change the collet, but I think we'll be all right. Now that I'm looking at it, so we can go ahead and check it and see if it is gonna crash. And what I can do is very carefully, I can bring it over to see if it's going to crash, right? So as I creep up on this, yeah, we're good. It's not going to crash. It's not going to crash. So we're okay. I'm going to go ahead and leave it in there. All right. All right. Yeah, it's close though. Okay. So. Oh. All right. What I need to do now is I need to tell the machine where my material is, and I've blocked off this corner, okay, with the clamps. What I'm gonna do, I'm thinking I'm gonna move that clamp. It shouldn't move. It's got 3 points on it. Okay, I mean, come on. And I'm gonna remove this clamp while I find that corner. Okay. All right. That's what I'm gonna do. So, I'm gonna use the edge finder, and we're gonna find user home. Okay, so that's tool 7 I need to be in, you'll see. So we go manual data input, and I'm sorry, I'm thinking T7. Okay. So let's go ahead and put our edge finder in here. And what I'm going to do is I'm going to warm up the machine a little. I warmed it up already, but I'm going to warm it up again. And not even gonna explain how to do that right now because it's too much, it's too confusing. Down here in the override section is where I can override some of my feed rate and my spindle speed, okay? And it says I can do it in 10% increments, or I can control it with the spindle, this handle spindle. And I'm going to do that. So I'm going to turn this up. My RPM is it's reading about 900, okay? And I'll just leave that there while I show you some stuff. Okay. So what I need to do is like I said, I need to tell it where home is. So I'm going to put in a handle jog, and it already took me to my offset screen. This says tool offset, length geometry here. And so that is how I'm going to tell the machine what my tool lengths are, which we have to do. But right now what I want to do is I want to go to work. There. Cursor over to work, and you can see there's my G54 that I was telling you about. So that's my user home, okay? And so what I'm gonna do while the machine's warming up actually, is I'm going to handle jog over to that corner. Okay. Z down. Yeah, the door's locked. Could override it, but I'm not going to. I'm going real slow, right? All right, so, okay. And I'm gonna put it into control by the... Okay, so I overrode the door because I want you to be able to see and all that. All right, so I overrode the door. All right, and all right, here we go. So X, back to offsets. Or work offset, G54. I'm gonna find my X. Okay, so and let's see here. Sorry. Alright, X. And jog rate, thousandths. Okay. So going concentric. Going concentric. And yeah, it just kicked out. It just didn't. Again. There it went. All right. Much, okay. All right. So, what I'm gonna do is Z up off the part. Okay, and I'm going to move the table 100 thousandths. And so we are in X, and we can see the machine is at this coordinate, and we're here. So we want to make that say 13, right? Yeah, 13. We want that to say 03. Okay? So now our spindle is on X. So what I'm going to do is it says part 0 set, and we're going to watch my -703 change places with that 10. I'm sorry, the machine is in 1703. Okay, sorry about that. And now we'll do Y. Same process. Just do Y. Alright, go Y thousandths place. So Y is highlighted, saying that's where I'm jogging, and its jog rate is 1/1000th of an inch. Turn this on. Kick this out a little. There we go. And here we go. Right there. Okay. So we'll Z positive off the part. Stop the spindle. Make sure everything is. You guys, I'm not screwing up here. It's hard to do this. Okay. And so I want to move Y. Okay, actually we can do 0.1. Why don't we just do 0.1? So it's going to move. Oh, it's locked. It's a setting. Never mind. Okay. So G54, the Y-axis is highlighted, and it says 13.514. So we want that to say 414. 414. Right? Okay, and you can see that we're lined up. So Y, sorry, I'm thinking, so this is highlighted, and we're going to see our machine coordinate 13.14 pop up there. So I part 0 set 13.414. Okay, all right, so let's get this up, because what I have to do is put a drill in here. So we got our G54, our user home. Come on. And I'm gonna put a drill in here. And I also take this away so I don't forget to do it. All right. And let's go to tool number 4. So and what I'm going to do is put that clamp back. So I don't forget. Not that I would forget. Let's just do it now. It's pretty good. There's that wrench. Back this off just a little. Still, that's making me just a little nervous still. I don't think it's gonna crash, but it's making me a little nervous. All right, snug that up. All right. I don't think that's going anywhere. All right. And now what I gotta do is I've got to find all my tool length geometry. All right, so starting at number 4 all the way to 11, I have to figure out where the tip of the tool touches the material. So that's what I'm going to do now. Bring it up close and switch to the thousandths place. Okay. And use a piece of paper as a feeler gauge. So make sure that you guys are seeing this. Right there, see it? Now for that, so about 3/1000ths off the, off the top of that. So 1, 2, that's fine. I'll just do that. And it says right here, tool offset measure. We can see we're highlighted in Z, and we're going to see 13.46 pop up to that. Make sure it's highlighted, and pop up to that. So tool offset measure. Yeah, I don't know what that is. I don't know what that is. Don't. And then move this off, positive. And next tool, so tool 5. Okay, and then we'll just Z down. Oh, handle jog. So T5, spindle, right? Tool offset, 5 is in the spindle, and it's saying the last tool, whatever that last tool was in there, that was its offset. So we come down here. Real slow. Thousandths place, so it's highlighted, right? And grab our paper. Okay. And you'll see 12.5. That never happens. Okay, got tool offset measure. Yes. 12.5 is up there. Go positive. 1. All right. And tool 6. Okay, now it's time to load my program. And let's see, so I got it on my flash drive here. And on here. Okay, so I went to list program. I'm going to cursor up to USB, and you see some of my files here, and then I got the lap steel folder, and let's see, hold on, yeah, I think you do that, yeah, that's how you do it. And then I got my G-code folder, that's the fingerboard, and then top copy, and it says here, it tells you what to do. So it says, you want to load that? I say, I sure do. So select program. There's my program. So T4, just like we had talked about, what this is saying here is the name of it, the date that it was created, Mastercam file. There's this, you know, my user for my school computer. NC file, lap steel 2, G code, top copy, that's the name of it. The material is aluminum. It's in inches. It's 6061. And T4. There's our list of our tools that we just did. Okay. And let's see. We can read the code. Remember, I was showing you that. That's the line number. There's our G54. Okay. H4 would be like a height offset for tool number 4, okay? And it's saying, okay, you're gonna go to Z positive 2, all right? 0.2, I'm sorry. And then you're going to run this, I don't want to get into it, but let me see what it's exactly called. Yeah. It's called it's going to run a cycle. It's called a CAN cycle, but I'm not going to get into it. And of drilling, of PEC drilling, down to negative Z and negative 0.15, okay? You can see here, spindle, S stands for spindle. That's spindle of 2000. M3's clockwise, I think. M3 spindle on clockwise. So it's saying here, it's telling the machine, spindle 2000 on M3 is on clockwise, okay? That's all I'm going to say about the G code, but there it is. I'm going to not use the door lock or fix the. I overrode the door. I don't want to do that. And so now we're all set, and I'm going to be running with coolant. Okay, it's a mineral oil based coolant, so that's why I want to keep the door closed. And then, but you will be able to see pretty well. And then I will. Yeah, I think that's it. I'm just going over making sure I got everything because I'm talking. So, oh yeah. So if we go to, let's see here. If we go here, yeah. What I'm gonna do is my spindle is on 400%, and so rapids. So I'm not going to get into rapids and all that, but I'm going to run them at 5% right now because I haven't proofed this program. And while this starts, I'm going to keep my my finger on feed hold just in case something happens. So here we go. Okay? See what happens. So it's moving into position. The spindle just started. All right, let's see. The coolant valve is closed. Want the coolant valve open. Kind of glad I kind of caught that. All right. Coolant's on, and we're off. So it looks like this one's doing pretty good. And so I'm going to kick up the rapid a little. Changing tools. I'm gonna turn the coolant down just a little. It's okay. No, I'm not. So that's looking pretty good. It's gonna do the perimeter. that's one of those pickup inside perimeters, inside contours. It's going to do another one of those, and then it's going to do a bunch of engraving. And then so what I'm going to do is, you know, I think you get it, and I'll just pick it up again when it's doing the final contour around the shape. All right, and all right. All right, so we're coming up here on the final pass. We're going to be cutting that profile now. So, only thing that I'm concerned about really is that the collet hitting the clamps, but I think we'll be okay. Okay, so it's done. What I'm gonna do, I'm gonna turn on the coolant pump, and hopefully I'll be able to spray some coolant here. Okay, coolant pump. Come on. There it goes. And I'm gonna clean as much as I can now. Turn that off, a little pressure, yeah. I know. All right. Then turn the coolant pump off. Then what I'm going to do, some air. Okay, and let's hand jog this over and see what we got. So there we are. Yeah, it looks pretty good. So I'm gonna pull this out so you can see it in better light. It looks pretty good. Just take me a moment actually, and we'll take it to the sink. I don't know if you guys know what Art Deco is. Art Deco is a movement, an art movement in the 20s and the 30s. And so this engraving in here, I'm no expert in Art Deco, but I did the best I could. And so here we are. Still dripping with coolant. I'm gonna go to the sink. So let's see if the light's better over here. I think it is. And we got some holes to tap still, but here it is. And there's the engraving. That's for the switch, and that's for the volume knob and the tone knob. And I put the date in here, 2020, and a little reminder to, you know, speak easy. So there it is. It's kind of cool. And I will see you when we tap.